Hello everyone, this is Mr.Efeturk. Now, chapter 6, we continue with question number 21, and in your DG, construct a parallelogram and determine whether it will tessellate or not, and drag a vertex to determine whether other parallelograms will also tessellate. Now here, we are just coming back to our GeoGebra. In GeoGebra, if we try to make a parallelogram by polygon, it will be a little bit difficult. So we follow a different way here. I just want to make the one line segment. For example, this is A, B, and to this line segment, I just need to draw one parallel line. Where is it? Yeah, if I will find it. Yeah, I want to make one parallel line to this. Let's suppose C point, from C point parallel to here. So between B to C, you see like the one, two rise and the one run. Or let's say ABC, AB is 1, 2, 3, 4 unit. So I need to make one line segment from C to D, 1, 2, 3, 4 units. Now it became CD and AB are equals each other, and also they are parallel. Now I can make my polygons. I'm just making my polygons from A, B, C, D, and again A. Now this is my polygon. This polygon I can just bring here a little bit more clear. And this line segment I don't need anymore. So I believe we can just hide this one. Yes. Now it is okay. Oops. What happened? Sorry. Like it means like we click more than side. This one I want to hide. Yes. Now this one we can move here. To do tessellation, what I do is I use the midpoint. Now I'm going to use midpoint of AB and the BC and the CD and of course the AD. From here, now I want to start with E. Let's go to our transformation. Rotate a point from this figure. I'm rotating from point E. So the rotation will be 180 degree. So it will come like this. And likewise, this one, if I rotate here, it will be 180 degree. And likewise, this one, if I want to rotate here, like with 180 degree, it will come here. So what I see here, there is a tessellation, and this one I can move anywhere, or from one of the vertex. Like if I just try to, it wasn't supposed to be, again it happened. This is the fourth time. Yeah, and yes, now it's okay. Like I just clicked something wrong. You see like my parallelogram, I can enlarge or to change the size of the angles and the size of the sides and the tessellation will continue like this, you see, like, yes. So what is the next question? We saw earlier like the equilateral triangle will tessellate. Will any triangle tessellate or not? Yes, I believe any triangle will tessellate because summary, like the very shortly speaking, or let's draw one triangle first of all. For example, I just want to draw any random triangle like this and like this. This is my triangle. Now actually for this triangle, if I try to make one thing, I want to go for the proof actually. How can I prove? Yes. Now I want to make parallel line from this point to this line. So, and after that, whatever is the distance here, it will be the same distance. Like for example, if the IJ is, let's suppose 5 centimeter, if I will try to make same distance, like the ij, for example, if I will make the same distance here, kl, not like that, let's make the line segment kl. I assume that kl is exactly the same as ij, like we can do calculation. And when we do our polygons from this triangle, I, J, K, L, and I. This is actually a parallelogram now. Why it is parallelogram? Because IJ and the KL is parallel to each other, or we could have done same thing that the J to IL, like if we do, for example, like the parallel line from J to IL, let's suppose. So it means like it didn't match exactly. Uh, what I wanted to show here is that any triangle is actually half of the parallelogram. Since this parallelogram can tessellate, if this parallelogram it can tessellate, so as you see, like we can make it, for example, I wasn't supposed to touch the other sides. Yeah. Yes, like this, for example, the angle of BDB, we can make it obtuse angle like this, or acute angle like this, or something similar to right angle, something like this, for example, like this. So inside this parallelogram, we know that we have already D, B prime, and the B prime sub 1. This is a triangle. So we know that this triangle is the random triangle. Because of that reason, you see like this random triangle can be uh, like wider, narrow angle, wider angle. So it is a random triangle. It's not a regular triangle, equilateral triangle. So every parallelogram, as a conclusion, contains inside like the two different triangle. So if the parallelogram can tessellate, definitely this triangle, we just need to make it double, and after that, like the two times, we need to follow the same operation. So another question is what?